I know it's probably not going to happen this year, like as a physical conference. There has been some great activity in the German Java user group sphere and putting everything online. But yeah, keep that on the radar, because whenever that comes back online, that's going to be roller coasters. Like literally, it's happening in a theme park. You've been there, Burr, right?
I have. I actually think that's a wonderful place to actually do a conference, because you get to ride roller coasters and learn about cool crap at the same time.
And you can drink beer outside. So thanks for letting me pitch that. We're going over Java and containers. Broadly speaking, asking the question if it is a good idea at all. I'll touch a little bit on what it takes to create effective Java images. I'll show you some tools, and as you might have noticed, I'm already running behind time, so it's going to be a little bit of a homework exercise. There are plenty of links across the slides. Burr is going to paste them in the chat window. I will make sure to give you something to dig deeper. And as Burr already said, there are a couple of more tech talks coming up that you can't miss, because some of them will go deep into the woods of the individual topics. So containers, yeah, we all love them, right? There are not enough coming our ways these days, but that'll change hopefully in the future. I got the question quite a couple of times, why the hell containers? Like seriously, why do I have to do containers now? I was so happy with my application service. And I found this slide. It's supposedly a marketing slide, but I still like it, because it kind of shows very in one cohesive way what happened over the last 10 years when we did waterfall-driven projects, like written 500 pages of spec documentations before somebody was even trying to write a single line of code. That was back in the centralized monolithic application space on physical servers, mostly in your own data center, right? So companies have been paying a lot of money putting that stuff somewhere in their basement. And all this shifted from the development process all the way to DevOps. From the application architecture, we now have microservices, and as the perfect deployment platform, the cloud. And the standard version to put your services somewhere definitely is somehow a container. And yes, there are a bunch of reasons why containers. So deployment is easy. Like, instead of wrapping up a custom tar file that contains half an application server, a bunch of your application deployments, configuration files, and getting that in the hand of ops and wait for like a year until they finally deploy it. So these days are over. You create a container image, that thing spins up somewhere and it's running. Scaling is a complete different, I'm not going to read that slide, but give you a rough idea. So there are reasons for containers and good reasons to use them. And if you really think about it, containers are everywhere. Like, we have been living in containers all our lives as developers. And you just need to look in front of you. If you look at your laptop, that somehow is a full-blown container, right? It is fully self-sufficient. It has an operating system. You can run stuff on it, right? So containers as a concept is not really new. I'm not going to talk about C groups and how this all is basically a Linux magic happening to enable containers. But it is something that has been there forever and is a very mature way of packaging applications. So it's any way but scary. It's nothing but scary. No, the other way around. It's not scary, and we can easily use it because it's something that has been out there for many moons already. The only difference is that in recent times, amazing tools like Builder actually made it easy. Instead of having to be a Linux sysadmin down to like 20 million commands, restricting CPU usage, memory usage, you now have a container definition that takes care for all this like heavy lifting. So there we are, containers in Java. I said we came all the way from the monolithic approach. We've been doing Java for very good reasons for many years. It is a very effective programming language, gives us all kinds of quality control. We've built so many tools around Java. Just think about continuous integration, continuous deployment. We've built testing tools. We build code coverage and quality tools. We have wonderful IDEs. If you haven't noticed, I love Java. So Java is a good fit for containers, at least on the first sight. If you look at the programming languages trend over the years, you could probably get the impression that Java is a little bit downwinding, right? So it seems not to be the most important language anymore anyway. Yeah, but I can tell you one thing. I personally will stop coding in Java whenever they make a better technology. And this is credit to Trisha Gee. She found this one on a conference, took a photo and tweeted about it. So, it was Heather actually. So the link is in there. Apologies. I love Java. So I really want to make this work. And I really want to understand what the drawbacks are ultimately. So let's think about Java and Docker image sizes, or image sizes in general. It doesn't have to be Docker. So just looking at this, and imagine we're talking about base images. So just a slim OpenJDK base image in this chart, where I forgot to put down the source, but I'm pretty sure I can dig it out somewhere, is 500 megabytes. The smallest one is the JDK8 JRE Alpine image and still has 85 megabytes. So obviously Java itself is a pretty big beast, and there's no application on top here, right? So this is just the base image. That makes you probably question if Java is still a good choice. And we've seen amazing things, right? We've seen Alpine images. These are like super small. I think they go down to like 4.4 megabytes, just the OS. And that seems to be promising. So there's a little link down here. It's a little dated, but it still is accurate as far as I know. So there are ways of putting Java in Alpine. It's not a normal Unix, right? So it's not a glibc-based Linux. It is actually a Musl-based Linux. And believe it or not, the JVM is written in C++, so that is not an easy thing to do, to port these over. There are some efforts in the JDK project and the OpenJDK happening right now to make it easier to port, but for now, just look at the blog post that I linked down there. It takes a little, and you don't really want to do this yourself. You're basically building a specific version of the JDK yourself in these images. So another way that seems to be very promising, according to my diagram a couple of slides ago, is going distroless. So meaning creating a specific image without any kind of dependencies on the underlying distribution, right? So Google came up with that. There's support for Java, Golang, .NET, all kinds of languages. It's an interesting approach in getting image sizes down. And I could go on quite a bit, but honestly, the question is, does size really matter? Is that really a thing we need to care for? Bert, what do you say? Like, is image size important or not? Just thumbs up, thumbs down.
I would actually say it's important in one key situation, specifically in an OpenShift or Kubernetes cluster, and you have to move those images from node to node to node to node, which is a common occurrence. If you have 25 worker nodes, you got to move them all over the place. So a smaller image size does help a little bit.
Okay, let's take a look. So does size really matter? Just imagine we have a really large base image, almost 1 gigabyte. And we have a couple of smaller project-specific images, right? So the magic is the base image is just a reference. So whenever you build a new image based on a really huge, large base image, the new one is actually smaller. So it is a little bit more than your project-specific additions or your layer-specific additions, but it's not completely copied over every single time. If you do a little bit of math, you get an average image size in that setting of 118 megabytes. And yes, I do absolutely acknowledge that copying this, even that initial base image from left to right has an impact. but technically speaking, that is happening once. So as soon as it got like distributed, and the beauty of base images is they don't change that frequently usually, it really doesn't matter anymore. So as soon as all the caches are filled and our smaller images are out there and getting frequently updated, you get a pretty small size. If you happen...
Actually,
yeah.
A question from Robbie that just came in is, do you actually know how they reduce the JDK size for the Alpine image, as an example?
Oh, yeah. I'll just paste that link from the blog post on that slide. Yeah. That is exactly happening. I think they're using JLint to just use the modules you need, right? So there's no magic. Okay. We all use the same tools. So back to image sizes. If you switch that around, and if you actually have a very small base image, and if you copy around a lot of application-specific stuff all the time, your image size blows up. And also the actual size on the physical storage that it is presented. So speaking of that combination, you'll end up having roughly 1 gig per image. This is definitely not something you really want to do. So size matters to a certain extent. I mean, not really, but to a certain extent. Base image size does not matter, right? So reducing base images because you want to save storage, like in a professional enterprise-ready setting, that is probably nothing you really want to do. What really matters are your frequently changing layers. So make sure to construct your layers accordingly and only change these things that need changing, and don't change the base image too much. What should you really care about when looking at image sizes? I think the most important part for smaller-ish images is that you are not exposing anything that is not necessary. That is especially important when we look at container security. So just the bare fact that you have a full-blown Linux running in a container that is only supposed to execute a JDK is probably not necessary. There's a bunch of features and functionalities. Just think about email clients, right? So, I mean, packaging managers and stuff like that. That probably that are not necessary. So be ready to smaller your attack surface for every single image. Yes, there is a time and cost perspective to this, as Burr already mentioned. So think about copying big images from your laptop to some cloud provider that you have to pay for traffic. So that is also a thing you might want to take into account, right? And last but not least, make sure you have an efficient tracking. So you need to be sure that certain images are secure, that all the CVEs are addressed, and that you are not running into any kind of issues, right? So that is important. And if I scared you, I'm glad, because that was kind of the exercise behind this. And there's obviously a solution. It's called the UBI, the Universal Base Image. Again, there's a nice blog post taking you through all the nitty-gritty details, comes in 3 flavors, gives you something to base your own images off, coming with everything you need, but not a lot more. So take a look at that. What is way more important is to construct your application layers the right way within your custom images. So if you think about this little scenario, so we have a 100 megabyte image and a 50 megabyte image. During the build, everything gets sent over. Obviously, the top one is the base image, and the bottom one is the application-specific image. Base image gets cached. The 100 MB turned into 72 because that is the size of the smallest UBI image. So just as a reference for you here. So every time you're sending your new application, your new updated image to the registry, you'll send 50 megabytes. That is quite a lot, right? If we take that down and think about how applications typically are constructed, there's an opportunity here. Think about the most frequent changes in your applications. Speaking of a Java application, that might be class files, right? So you build an application, you compile your class files, and what really needs to be sent are the class files, and not the 9 megabytes of resource files, or the 40 megabyte of images, right? So that is something that might actually stay stable for longer. So taking these layer image into some kind of Docker file example basically shows you that, right? So you will have your libraries and dependencies that very rarely change. You will have certain resources, and the ones that are actually changing very frequently are your class files. So whenever you're building your images, just make sure you're building them correctly to speed up your local development environment.
I so much like for Marcus. Just to jump in, I actually love that point, sure. And I think it's a good one. I also mentioned in the chat with people, because one thing that I really love about that is it's one thing to have that experience on your desktop where you're building images maybe every 30 minutes or maybe every 5 minutes or every hour. But if you're doing it in a CI system, which is building them constantly and churning out those registry updates constantly, you would feel pain there if you don't have proper layers in your image design.
Yeah, and you get more pain the more non-cloud native stuff you're using, right? So, for example, a classical Jenkins installation versus Tecton pipelines, right? So, I mean, there are even ways to be very cloud native and Kubernetes native in this. But yes, I mean, hey, we want the fun back. I mean, as a Java developer, I have a slide coming up, so I'll talk about that a little bit.
And later. That 40 megabytes is not WebLogic you're talking about there.
No, for sure not. For sure not. So yeah, what else is there around Java and containers in general? So I said cloud, right? So we're paying somebody for our runtimes. That might be somewhere with whatever public cloud vendor, or even if you have your cloud in your basement, you're still paying for it, right? So let's look a little bit at the typical Java application memory usage. This is kind of the startup behavior of a cold JVM. You see that after a certain time, we have a little bit of an overusage and we have a startup lag. The startup lag is something that we really don't want to have in container world. I mean, just imagine that your service takes, 30 seconds to start before it's ready, but the load's here already. So you're putting these 30 seconds on your customers waiting for that web shop to refresh. And the overpeak usage, what is that? That is something you'll have to pay for, you get nothing for. So until the JVM really went through all the warm-up and pre-compilation phases, there's a garbage collection run, and that gets rid of that overpeak usage, right? But you're paying for something that has no business value, so you don't want that. What you really want to save dollars is something like this, instantly there, and a very clear behavior when it comes to maximum usage. Yeah, how do we get there? Good question. So a bunch of available Java runtimes. We all know that there's been a little bit of hiccup since Java 8. We all switched from Oracle Java to OpenJDK via various distributions. I'm not going to tell you what the best ones are. I strongly believe that there are reasons for all of these, and that there are good approaches in using them in certain, at the end of the day, I've been an architect, so my general answer will be it depends. So whenever somebody asks, but OpenJDK usually is a very solid bet. So can we use Java ADU121 in containers? Do you know that, or is that a good choice?
You got to just have a little fun with it, though, because it might blow up on you.
Gotta have a little trust, man. Yeah, right. Yes, you can, but there's been a lot of container awareness coming to Java since that Java release, and it actually makes the JVM recognize the assigned thread, the assigned CPUs, the assigned memory amount. It makes running Java in containers ultimately safe. So if you want to start using Java in containers, you should definitely start with ADU131 and nothing below that. Unfortunately, that is probably going to be a challenge because of the changed licenses. But anyway, there's so much more coming. And just looking at the time, I'm getting a little bit scared here. I'm not going to walk you through all the individual things. So that's going to be your homework. There's been a lot of improvements happening in all these various Java versions, and even up to 14. And Burr, do people get the slides afterwards if they're interested?
Yeah.
Because
Yeah,
I intend on just scrolling through here and not talking about them a lot more. So yes, Java Flight Recorder was integrated and added some improvements for containers, so you get more information about what's going on inside your JVM and around. And even Java 14 added a new feature that has been on the list, and there's still some more stuff coming. Yes, the accelerated Java release cycle definitely changed the game here and gave us a good opportunity to embrace new features a lot quicker. I'm kind of curious to see what comes next. There's so much that we have not even thought about right now. The message here is, yes, it's safe whenever you start using it from 8.1.3.1, right? So JVM Troubleshooting and Monitoring, that is another big thing, because containers, networking and exposing ports and stuff like that, so that is not an easy thing to do. But again, take this slide as kind of your inspiration whenever somebody needs to look into what's really going on inside your containers. This is a good set of tools that you can actually use, and I'm pretty sure I missed a lot of things in here. Especially my favorite, Java Mission Control, flight recording. That is definitely a super helpful tool. Build process changes. Yes, so the lucky Java developers, just a couple of years ago, we've been in that left two boxes, right? So we had a project, we built that, and some deployable came out of that. And now this whole thing is taken to the next level. So we need to take care for something that describes the assembly, including the operation system. We need to have some way of building that image. That image needs to be pushed to a central registry and put into some kind of container orchestration. And I'm just realizing that I didn't even touch on YAML files here. But yeah, obviously, whenever you want to orchestrate something, you also need to take care for how that orchestration works, right? Seriously?
Hey, one question that just popped in that is interesting from, and I think I have the name correct, is Kieran. But great talk so far, but they're interested in knowing about code coverage metrics from inside the container.
What exactly are you looking for? Like code executed while running in a container?
I'm wondering if it's about Flight Recorder and tools like that, right? To get
Yeah, but Flight Recorder can't do code coverage, right? I mean, code coverage is something like Jacoco, and I don't see a reason why you can't run Jacoco on a binary in a container. The only thing you need to take care for is where to get these reports from, right? So make sure to put them into some kind of persistent storage. I think the difference shouldn't be that much. Usually you're using the same JVM, and that should give you the same results by doing the same actions with like a test set, if locally or in a container. So that wouldn't be my biggest worry, but there is no like additional remote way of doing that. So again, I, as a Java developer, I don't want to have to take care about Docker files. I don't want to think about images. I want to be productive. And I do think that is still true. And yes, Burr knows I've been working with containers even before Kubernetes. There's been stuff around gears and the first OpenShift versions. That's been fun, but yeah, it's fun. It's nothing that makes me productive as a Java developer. So I need some help, definitely need some help. And thank God there is a lot of help out there. So the historic Fabric 8 Maven plugin is still maintained, correct me if I'm wrong, I think in the process of moving over to the Eclipse Foundation under the JCube label. It is not a one-on-one transformation. There's a couple of more Kubernetes tools and stuff. But yeah, keep an eye on that project because that is definitely going to improve a lot more. We have a couple of Docker Maven integrations. Don't ask me why so many people thought it is a good idea to develop so many things, but that's the beauty of open source. I mean, ultimately, nothing stops you from doing that via the Maven exec plugin, right? And calling like local Docker way to build or builder to actually build your image. It's not elegant, but it works. So whenever you feel like playing, and because that was only the Maven side, the Gradle side does look pretty much the same. So there's plenty of alternatives for you to pick from. What is still missing is the intelligence that is put into building the right container layers and images. And I mean, I said I'm a Java developer, right? So I want to be productive, and all I want to do is write code and not take care about that stuff. In that case, I definitely recommend looking at Quarkus, because Quarkus does that for you. Like the build step is building your images in the right way with the right layers, and they're already taking that into account. But there is a lot more coming up about Quarkus on April 23rd, same time, same place, with Max Anderson, if I'm correct. And he'll probably walk you through everything you need to know around Quarkus. But yeah, take a look. So what else is there? If you really don't want to work with any kind of these like container thingies at all, you need to take a look at Odo. Odo is a developer CLI. It gives you everything you just even distantly thought of whenever it comes to handling code. So you interact with Odo as you would with Git, basically. And you don't have to care for images. That's all built inside OpenShift. So it's hidden from you as a developer. So take a look. There's a bunch of IDE integrations, obviously, especially from us and the amazing team from the Red Hat developers that will definitely help you deploy stuff to your Kubernetes environments, and especially OpenShift. So take a look at these. Will make your life a lot easier and feels a little bit more native. If you want to learn more around Red Hat developers, what we do, what amazing content we have, what amazing event series are coming up, you can definitely sign up at developers.redhat.com. Burr, what did I miss? Like, what are people also finding on developers.redhat.com? I missed a couple of O'Reilly reports and books, right?
Yeah, there's tons of free ebooks that are out there that people might enjoy. Of course, the cheat sheets are insanely popular. But the video, we have a video series, the DevNation, of course, which is what we're doing right now, is also very popular. So lots of good options out there at developersred.com. And then we're basically out of time. I tried to add the links to the chat. We got all those out to everybody here. There was some interesting discussions around, layer design. And might be one thing that we will go back to. You mentioned Jacoco as an example.
Yeah.
But what if I don't want to put that agent in my container? So that's an interesting one. I don't want the agent in my container, but I still want Jacoco-like features.
So here's a very German answer, and I want you to take that with a grain of salt. So somebody said to me, no arms, no cookies. I mean, you need if you want to use Jacoco, you need to use something, right? I mean, I personally don't know about any kind of code coverage tool that runs on binaries. I'm not even sure if there's something that runs on the static Java code, on the not compiled code, right? So, I mean, Burr, you?
No, it's an interesting concept, but in almost all cases, right, what we're seeing is every tool that existed prior to containers has been moving to containers over time. Java itself is one of the slower ones to kind of catch up on that, as you've shown in the presentation today. So most agents are perfectly fine in containers. So if there's an agent from somebody, typically it's not a problem running in the container at all anymore.
Yeah, I mean, that only so many options you have, right? You can define some sidecar, but even that sidecar has to communicate, right? So unless you have a fully integrated monitoring solution that really deeply links into your runtime environment or container platform, you will have to do certain things.
Well, and a good tip here from Sebastian. He says, in France, we basically say if you have no arms, no chocolate.
Good. Perfect.
We do have to kind of get off the line. We're running a little bit over, but Jim had one last question that I think is still pertinent here. Should we set the Java heap size when starting a Java app or Java jar?
Why should you? You definitely will have to if you restrict your container.
Right.
So if you don't restrict your container, you won't. But it depends, again, on your setting, right? If your containers are only allowed to have certain amount of memory, you better restrict that, JVM.
Either you set it explicitly or at least know what
you'll
the
find
JVM
out.
compilation is going to be. Find out the hard way.
Yeah,
by
exactly.
default, the JVM will try to grab a quarter of all available memory on the machine, and then of course if C groups constrains it, it blows up. So that's the traditional OM kill.
Yeah, exactly.
Okay. Well, thank you so much for that, Marcus. We had a great time, and actually the topic I think was incredibly pertinent because oddly enough, we actually discussed many of these topics in our master course this week. So I saw some people in the chat who just saw some of this from us earlier in the week, and this really enforces the idea because people are looking at how to run their Java in containers more successfully. Awesome stuff. Thank you so much for that.
Thank you so much for having me. Stay safe and healthy, folk. That's
absolutely
super important.
So we're signing off, and we'll see you guys in the future. Thank you so much.